Welcome to Module 204F on diagram conversion. It's not enough for us just to be able to read a diagram, but we have to be able to understand the diagrams well enough that we can transpose them from a wiring diagram into a schematic diagram in order to facilitate any troubleshooting. This module is all about how to manipulate our drawings so that we can better use them, even by creating our own schematic diagram for troubleshooting purposes. This module has two different objectives that we'll be going through, and we are going to start with converting a wiring diagram to a schematic. Wiring diagrams are great for installation purposes, but when it comes to troubleshooting and understanding what is happening within that circuit, the schematic diagram is really where we should be looking. Whenever we have either a wiring diagram or even a piece of equipment in the field, we can take the information that we can find within that and create our own schematic diagram. The most important aspect to this is to make sure that you are organized. There are many different methods we can use for diagram conversion, but they all start in the same place, and that is with the labeling of the components. The labels represent all the different points that are connected by the same wire, such as with our 1s, every place that is on the same connection is all labeled with the number 1. We'd follow that through with our 2s, our 3s, and our 4s. By doing this, that we can identify that if I had, for example, a blue wire connected to terminal 4 in my start-stop station, then that blue wire would also be connected to terminal 4 inside my controller. When it comes to physically putting my wires underneath the terminal, even though I have two wires possibly going underneath the same terminal, I need to identify that as being a splice or connection. On my schematic diagrams, I would show it as a node, and I would be able to see on my wiring diagrams that when I have multiple lines going to the same connecting point, it's the same thing as putting multiple wires underneath the same screw. I should also be making sure that any contacts are labeled the same as the coil that is controlling them, such as for my A coil, all my 4 contacts will also have an A associated with them, and then I can also add numbering so I can identify each one of those contacts separately from each other. Once I have my wiring diagram organized and labeled correctly, I can now take that information and start applying it to my schematic diagram. I want to start with 2 vertical lines representing my power source. After that, I have to remember that any of my load devices are going to go on the right-hand side and any of my control devices are going to be going on the left. My next step is to start placing the components within my wiring diagram into my schematic diagram appropriately. At this point, you want to keep in mind where the numbers are, and you want to line up the numbers the best that you can to make it easier to interconnect them later. Once I have my devices placed onto my schematic diagram, I'm also going to take any contacts that I have within my wiring diagram and place them in there as well. I usually do the contacts on a separate step simply because it's going to be easier for me to be able to line those up with the components that are in the schematic diagram. Once I have all my components and all my contacts in there, the next thing I need to do is just connect the components number by number in order to represent the wiring. This is similar to connect the dots, so all the terminals that are labeled with the exact same number should be connected together. When it comes to line number 1, since they both go back to my L1 source, I could also represent it like this, and this would be completely accurate. Use this method if you find your drawing is getting a little bit too complicated, and if you find that this is going to simplify it. Go through your drawing slowly and double check your connections on the wires to make sure there are no mistakes. And if you have any crossed wires, you can always redraw your circuit in order to simplify it. Another method to make things easier for you is to color or label the wires in order to keep them clearer for you. Using this method, it's relatively easy to take any kind of wiring diagram and break it down into a schematic diagram. Keep in mind, with a wiring diagram like we see on the screen here, we would only be taking the control circuit and applying that to my schematic diagram, and we would not be paying any attention at all to the power circuit. If our controllers already have markings on the contacts themselves, such as we do with a NEMA contactor, then we should apply those numbers to my drawing. I should also keep in mind that all the wires that are connected together from any one of those points should also share those numbers. I'm going to want to trace each and every wire through each and every contact and make sure that everything is labeled exactly the same all the way through. If I have any wires that do not have labeling on them yet, now is an appropriate time to do that. And I can associate any type of label I want, whether it's another number or a letter or anything else. Keeping in mind, coloring your wires is a great way to keep them organized. From line 1 to my stop button, I do have a wire there, so I'm going to label both ends of that wire as a number 1. Also, from my motor coil to my overload relay, I have another wire there that I'm going to arbitrarily give a number 4. And then from my overload relay going back to line 2, I'm going to arbitrarily give that the number 5. Now I have all the wires in my control circuit fully identified, and I can start applying those down into my schematic diagram. With my schematic diagram, the first thing I want to do is start placing my components in there. I'll take all the components I have in my wiring diagram, not including my contacts at first, and I want to place them into the schematic diagram. The one thing I do have to pay attention to is which way the numbers are facing. For example, if I look at my stop button that I placed into my schematic diagram, it is facing the exact same way as it is in my wiring diagram. Keep in mind that things don't have to be physically accurate when we come to a schematic diagram. Since my line 1 also has the label 1, I want to match the numbers on my devices to other numbers on other devices. So it would be better for me if I took the stop button and reversed it. Now my 1s are pointed toward each other, and as I place other devices into my schematic diagram, I'm going to try to make sure that all the numbers will align. My stop button will come in next, and I'll have the 2 terminals facing each other, and then my coil will come in after that, and I'm going to have the 3 terminals facing each other. Next, I want to make sure I get my contacts in here. I have 2 contacts I have to think about. I have my holding contact and I have my overload contact. First, let's look at the holding contact. I can see that the numbering on my holding contact and the numbering that are on my normally open switch are the exact same numbers. This is an indicator to me that these 2 items are meant to go in parallel, so I'm going to move that down so it's going to be parallel to that start switch. After that, I can place my overload contacts, and I can see that it's going to go between my motor coil and my line 2. My line 2 will have the number 5 on it, and as long as I line up all the numbers together, this will be done correctly. The last thing for me to do now is simply connect the numbers together. So I'm going to start placing the lines that I have in my wiring diagram onto my schematic diagram, starting from 1 and working my way over until I come to 5. First, I want to go from line 1 to the number 1 terminal on my stop button. Then from the number 2 terminal on my stop button, the other side, I'm going to go to my normally open switch and to my normally open contact. From the far side of my normally open switch and the normally open contact, those are both labeled with a 3. They go over to the number 3 terminal on my coil. Coming out of the secondary side of my coil to my overload contacts, I have number 4. And from my overload contacts to line 2, I will have number 5. I've now completed taking the control circuit from my wiring diagram and putting it into my schematic diagram, and now's the time I want to take another minute just to go through and make sure that all my terminal points and all my wires are all labeled correctly and are going to the correct positions. Now that you've seen this process a couple of times, I have a few drawings in Blackboard in which you can practice your skills. Make sure you go through them and you are comfortable with this process before continuing on. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.